Now we're going to talk about angles that have a vertex in a different place. We could have a vertex inside the circle, or we could have a vertex outside the circle. So remember, if the vertex was at the center, the angle equals the arc. If the vertex is on the circle, the angle is half of the arc. And now we have two more rules. If a vertex is inside, but not at the center, the angle is half of the sum of the arcs. So that's half of arc plus arc. So in this first picture, if I want to find these angles, now notice those are vertical angles, so they're going to have the same measure. So I could find either one of those. The intercepted arcs that go with those angles are the 42 and the 58. And the rule says if I want to know these angles, I'm going to do 1/2 of 42 plus 58. So let's take our calculator. 42 plus 58 is 100, and half of 100 is 50. So both of these angles are going to measure 50 degrees. Next up, I have this picture. Now I know my angle is 50 degrees, so that angle is also 50 degrees. And my rule says that these two intercepted arcs added together, x plus 25 times 1/2, is going to give me my angle. So to solve this, the quickest way is to multiply both sides by 2. And we get x plus 25 equals 100. You subtract 25 from both sides, and x is 75. Here's a little trick I like to use. I know that my vertical angles are each 50, so 50 plus 50 is 100, and I know that these two arcs also have to add up to 100. So 75 plus 25 would give me that 100. Okay, so for my next one, notice they've given me this 120 degree angle, so I know this angle is also 120 degrees, but that's not the angle I need to use. This arc goes with this angle. So I need to find these angles before I do the rest of my problem. So remember, we have linear pairs. This is 120, so the one next to it was 60. So my angle is 60 degrees, and that equals half of my arcs added together. So remember, when we see this, let's get rid of the 1/2, multiply both sides by 2. So 120 equals x plus 40. When you subtract 40 from both sides, you get 80. So 80 plus 40 is 120, and half of that is 60. All right, another one. So this time they've asked us to find x and y. I think I'm going to find y first because I have a linear pair with the 22. So 180 minus 22, we can grab our calculator for a shortcut, is 158. So y equals 158. We're done with that one. Now let's find x. The angle 22 is half of the intercepted arcs. Sometimes I refer to them as vertical arcs. That's not an official term, but they go with the two vertical angles, go with those two arcs, the x and the 65. So if I multiply both sides by 2, this becomes 44, and this problem does not actually work because if I subtract 65 from both sides, I get a negative answer. So we're going to cross this one out because we can't have a negative value for our arcs. So pretend like that one never happened. Let's move on to the next section where we have a vertex that's outside the circle. All right, center, angle equals arc. On the circle, half the arc. Inside, not at the center, it's half of arc plus arc. One more rule. This time if the vertex is outside the circle, the rule says the angle is half of the big arc minus the little arc. Okay, let's see how that works. There's several different ways that we could have that picture appear. So notice this one. We want to find x, the angle whose vertex is outside the circle. So the rule says the angle equals half of, now notice we have two intercepted arcs this time. We have the 105 and the 15. The intercepted arcs are inside the angle. So the rule says I'm going to subtract those and then divide by 2. So 105 minus 15 is 90, and I know that half of 90 is 45. All right, let's try the next one. Now I'm looking for this arc. So notice I've got my 25, and it intercepts these two arcs, the 150 and the x. Angle equals half of big arc minus the little arc. The big arc is always going to be the one that's furthest away. So remember, just like we did in the problems above, to get rid of the 1/2, we multiply by 2 and get 50 equals 150 minus x. And we solve this. Some of you could probably just look at it and tell that x is going to be 100. 150 minus 100 is 50. Alrighty. Now this one. Let's see how we're going to figure this one out. Let's pretend like I gave you some more information. We're going to say this one was a tangent. Looks like it wants to be a tangent. And let's say that I told you this was 100 degrees over here. And now we'll see what we can figure out. Remember that a circle is 360 degrees. So if I add up 200 plus 100, I need 60 degrees to be my inside arc, my little arc. So now I'm going to say that my angle equals half of the big arc minus the little arc. So 200 minus 60 is 140, and 140 divided by 2 is 70. And in my last picture, so if you take a look at these, I call this the dunce cap picture, because if you remember, you know what a dunce cap is, what that looks like, kind of looks like that, kind of like what Jack in the Box would wear. Anyway, so these are both tangent lines, which really doesn't matter so much to this question, but the intercepted arcs are this one, the 2x plus 52, and this one, the 16. So we're just going to follow our rules. The angle equals half of the big arc minus the little arc. So I've got to simplify my parentheses. 52 minus 16 is 36. And we could distribute the 1/2, or we could do what we've been doing, where we multiply both sides by 2 to get rid of the 1/2, and then solve it from here. So I take 120 minus 36 and get 84. And now when I divide by 2, x equals 42 for this question. So it all depends on the vertex. We have 4 different rules. If it's at the center, the angle equals the arc. On the circle, the angle's half. Inside, half of arc plus arc. Outside, it's half of arc minus arc. So concentrate on where is the vertex of my angle and then apply whichever rule goes to that vertex.